Hello and welcome to another video presentation by the UNT Physics Department, courtesy of the Physics Demo Room. Today we're going to be talking about is velocity, and in particular, velocity when it comes to fluids in general. So what I have in front of me here is a juice bottle, which if you notice has a piece of black tape at the bottom. Well, what we've done with this juice bottle is we've punctured a hole at the bottom. And then, if you can see right here, we've just filled it up with water. So we filled it up about halfway to 2/3 with a bottle of water. And what we're going to do is we're going to look at how does velocity go out of this bottle. And you know that we put it at the bottom and not the top. Reason why? Because we put it at the top of the bottle. After a little bit, all the liquid will no longer be at that point of allowing for the water to exit, and the experiment would be ended. So now, most of you might think, oh, I have this bottle. I take off the tape now. Wait, there's a hole there. But nothing's happening. Why is that? Corey, some of you might be saying, there's obviously no hole, because if there was a hole there, all my liquid would be falling out. And typically you might be right. But we are forgetting a concept that we might have seen a little bit before dealing with vacuum and with air pressure. This created a little bit of a seal. We have our air pressure inside. We no longer have anything forcing it to come out because this is completely sealed. So now, let's watch what happens when I open up the cap. As you can see, not very clearly, but hopefully you can hear, that I now have water escaping the jug now, and you can hear it. So why is that happening? And it's all because we have pressure at the top. That air pressure is pushing on the liquid and it's allowed to escape the hole. Beforehand, we didn't have that extra pressure, so the pressure on the outside was actually helping keep the water in. But now with this velocity, we can actually calculate how far, what's the speed at which it's going out. And that has to do with the density of water and what is the total height that it has to go to. I believe that's usually denoted as rho GH. Will usually be our velocity that we can kind of convert to, and that rho GH can equal to 1/2 of mv squared. In this case, it'd probably be the mass of water. So that is one of our two possibilities of looking at the different speeds correlating to different heights dealing with water pressure. So to continue on with our little demonstration before with using this velocity Efflux jug and a water and seeing how with pressure and then having a hole at the bottom, we can see water coming out in relation to how tall the actual water is. But some of you might be saying, well, Corey, what about if we had holes at different heights? And that illustration can be shown with this. It's another tool that we call the velocity Efflux, just a flask or a cylinder. And what I'm going to do is I'm going to actually pour this water into this, and we're going to catch it in our jug or in our pail. So as you will see here, I'm going to keep this guy or this flask on the edge of this pail. That way hopefully it'll catch all the water. And what I'm going to do is I'm going to pour water just into it, and we're going to see at the different speeds at which we shall see them shoot out. So as you can hopefully see, after a little bit of time, the top one was running the slowest and it disappeared. This middle one is now starting to slow down because we're having less and less water. There's less and less pressure pushing out the water. As you can now see with the bottom one, it's starting to slowly diminish of how far it's going. It's because there's less and less water above it that's pushing out that can escape. And all has to do with the height at which the water is going. So now let me retry that again. So as you can see, the very bottom one is flowing off farthest, second one was next, and the top one only lasted a little bit of time before it all of a sudden disappeared. You can see the second one, it's starting to get less and less because there's less water there. So this is where, with this case, the amount of water exiting has to do with the amount of volume and the amount of water that's in our tube above the exit pipe. So this is where, if you're trying to get water out of something, if you have it up here at the very top of your cylinder, all the water below it will not help add to the speed. This is why sometimes people will use a siphon to help get liquids out of a container, but due to you having to be at a different height, such that you're exiting at a lower height, you'll usually siphon out and have your container at a lower height than the actual vessel that you're trying to get the water from. So, as we kind of conclude with our little demonstration about velocity and water leaving systems, all having to deal with the amount of water or the height at which this water is going to be stored at, and its actual exit point, and how much that is going to change the velocity. This is all basically related to is the concept of energy. The amount of potential energy we have here is going to equal the amount of kinetic energy that's being released at the bottom. Well, thank you for listening to this video demonstration, and have a wonderful day.